before, there is reciprocal function. You have learned it before in high school. This is one of the rational function, okay? Yeah, we want to talk about special function called rational function. Okay, those who just came in, please key in your attendance. There are many that haven't keyed in. The simplest rational function is this. Okay, you also call it the reciprocal function. That is, if I give you y equal to 2 over x. You see, when we talk about rational function, and if I give you this, y equal to x over 2, it's not a matter of divide. This is not a rational function. This is a linear function. The x is power 1. Are you clear? So this is a linear function. So this graph, it will look like this. All right? It'll pass through the origin. Am I right? So when I talk about rational function, that means the denominator involves the variable x. Okay, I can also have a rational function that involves exponential. So that one we don't want to talk. So we want to talk about rational function. So when we, in maths, when we talk about a function, when you talk about a function, there is a domain, yeah, the object and the image. You study this in high school, correct? So every object must have a real image. So if in this case, if x is equal to 0, what will happen to your y? No, you don't say infinity. 2 divided by 0. We call it undefined. No one go and define it. You cannot say infinity. No one know. No one go and define what is the value of 2 divided by 0. Are you clear? So we call it undefined. So which means that the image is not real. There is no image when x equal to 2. So that means x equal to 0, x equal to 0 cannot be part of the domain. Do you get me? X equal to 0 cannot be part of the domain. So therefore, when you talk about rational function, first thing they will ask you to find the domain. So when you talk about rational function, when you want to find the domain, you must take whatever at the bottom of the rational function cannot be equal to 0. So therefore, whatever x, this is the bottom, cannot be equal to 0. So therefore, I will put it like that. The domain equal to x. X is a member or real number, can be any real number except x cannot be equal to 0 for this case. So for rational function, we definitely will ask you to find the domain. So what is the difference between a rational function and a natural log? Natural log is whatever in the bracket whatever in the log must be greater than 0. For a rational function, whatever at the bottom of the rational function, it cannot be equal to 0. So this is a very important thing that you have to take notes. So this is not a rational function, the reason. Hello, are you clear? Okay, so do you know how to recognize a rational function? Okay, I'm going to give you a more complex rational function. Okay, shall we? I have 3 inside my graphic calculator. Yeah. So we shall talk about the first one. So I have, okay, let's go by example. Huh? Can those in the on the online, Shinpei and Yijing, can you please switch off your mic? Turn off your mic. Yeah. Example 1. Huh? Okay, given y equal to fx equal to 2 minus x divided by 3x minus 5. Okay, the very first thing they definitely will ask you, find the domain. For this function. So now you know what to do. Yeah. Then second part, all rational function will have a vertical asymptote. They will ask you to state the equation of its vertical asymptote. Usually vertical asymptote is a vertical line that make the function undefined. See, this is a normal thing that any function given to you, we will always ask you to find its x-intercept and y-intercept. Okay. Then part D. Describe the changes. Hello, start doing already. Of y as part 1 x approaches over 3 from right. Part 2, x approaches 5 over 3 from left. So there is one very different from natural log. Natural log only from one direction because the domain is greater than. Are you okay? So can you try your best to do in 5 minutes? Then, okay, so I will discuss for part A before I start to write what is the domain. If you can get it straight away, you can straight away write down the domain. So for part A, I will say 3x minus 5, that is the bottom, cannot be equal to 0. So my x cannot be equal to 5 over 3. So therefore, the domain is equal to x. X is a member of real number and x cannot be equal to, hello? No. Usually if we write equation or this one, we will write it as a mixed number. Are you clear? When you write in the equation, don't change the number to mixed number. Always put it into improper fraction. Cannot be 5/3. Yeah. Hello? Got it? It's not the numerator, it's the denominator. Because just now I told you already, something divided by 0 is undefined. Not 0. 0 divided by something is 0. 0 divided by 5 is 0. I'm very generous. I got no money. I give to 5 people. Everyone also no money. Am I right? So it's defined. Are you okay? So that is how you get the domain for what type of function? This type of function. So every function, the way to determine the domain, there is a way. You have to memorize it, no choice. Okay. So for part B, the vertical asymptote. Okay, let me go to the next page. So when I plot the graph for this rational function, correct? I know x cannot take this value. So this is also called the vertical asymptote. Do you get me? The value that make the function undefined. That is also the value of x, one single value. Yeah, that is also called the vertical asymptote. So rational function usually will have vertical asymptote. You get me? So therefore, state means you look, you get the answer. The vertical asymptote is, you must write down x equal to 5/3. Equation always write as improper fraction. Sorry, I mute myself. No wonder they cannot hear me. Okay, sorry. So it's -2/5. So therefore, the y-intercept is -2/5. Okay. So I'm going to do part D based on my page 3. Okay, look. Part 1 is from the right. So now, if you look at my graph, okay, just now what is the y-intercept? X-intercept is 2, correct? This is 2.5. So x-intercept is here, 2. And the y-intercept is -2/5. Here. Okay. So the graph will pass through this point and this point. Yeah. Okay, so let's see how it go. So now I want to know what happened to the y as it approach. Yes. 5/3. Okay. 5/3. So it's wrong, no? So the x-intercept, the position is wrong. Am I right? So the position should be here. So the x-intercept should be here. Yeah. Am I right? Okay, so now 5/3 is approximately 5 and 2/3. 1 and 2/3. What am I talking about? So this is approximately 1.6667 and on. Am I right? Okay. So why I need approximate number? Because I want to know what happened as it approach here. So I write down as x approaches 5/3 from right. Okay, so now that means I have to choose a value of x which is more than 5/3. 1.667. So I choose about 1.7. Can or not? So if x is 1.7, my rational function, I have two parts. One is the top, that is 2 minus x. Am I right? Am I right? Okay, now let's have a look. Wait. So what happened to 2 minus x? It will approach what? A number. 2 minus 5/3. You will approach hey, how to be 0? 1/3. You are right. I think you all use calculator too much. It will approach 1/3. Am I right? What happened to Miss Doe today? 1/3. Correct? Then the bottom is 3x minus 5. It will approach. It will approach 0. But it's positive. Am I right? It's positive because it's from the right. So therefore, my fx, which is a fixed number, that is 1/3, divide by 3x minus 5. That means I will imagine it like that. 1/3 divide by very, very, very small number, which is like that. 1/3 divide by 0.000001. So it will approach. In 1/3, there are how many 0.0001? There are many, correct? So this one become very, very big. So it will approach infinity. So the graph will go like that. You get me? Hello, are you okay? So this is part one. Okay, then let's look at part two. As x approaches 5/3 from left, okay, now 2 minus x definitely will approach a fixed number, correct? We also call it 1/3. But 3x minus 5, this x is smaller than 5/3. Am I right? So therefore, 3x minus 5, it will approach 0, but the value is negative. Agree with me? It will approach 0, but you have to tell yourself that this value is negative. Because 3 times of a number less than 5/3 take away 5, definitely the value will be negative. Am I right? Okay. So therefore, my fx, which is 2 minus x divided by 3x minus 5, will approach what? Yeah, will approach negative infinity. So this part of the graph will go this way. See or not? So what happened to here? You have to study if you want to know. I'm just telling you how to talk about the limit. Are you clear? So if I want to know as x approaches infinity, what happened? What happened if x approaches infinity? Okay, we can do this in such a way. I'm going to teach you how to study. I'm going to change the function so that you can understand it better. So everyone have a look at this. So I'm going to change the function fx is equal to 2 minus x divided by 3x minus 5. X, what happened? X cannot be 5/3. So now, if I rewrite the equation as like that, do you understand what am I doing? Do you understand what am I doing? I divide every terms in the rational function with x. Okay, so now that will make me easier to understand the whole thing. If I talk about as x approaches infinity, what happened to my 2/x? What happened to my 2 over x? Hello? A very, very small, what is it lah? 0. What happened to my 2 over x minus 1? Negative 1. What happened to my 5 over x? Approaches 0. So I'm taking term by term, you see. Then what will happen to my expression 3 minus 5 over x? Approaches 3. So as a whole, my fx will approach negative 1 over 3. So this is the horizontal asymptote. You see, that's why I put the rational function last. It's more complex, more things to talk about. So for rational function, if you want to talk about as it approach infinity, correct, you change the structure of the function. So that it's easier for you to analyze. Are you clear? So same go with another direction. So you change it to this form, so easier for you to see because you divide by x. You get me? So that you can imagine what happened. Are you okay? So this is another technique. So same go with as x tends toward negative infinity, it will be same story. So can I move to the graph? So the as x tends toward negative infinity, so go term by term, 2 over x will tends toward 0 as well. Okay, so 2 over x minus 1 will tends toward negative 1. 3 minus 5 over x will tends toward 3. So therefore, my fx will tends toward negative 1 over 3. So this is the horizontal asymptote. So you see, if you look at rational function, it is much complex than the exponential. Am I right? It can have vertical asymptote and it can have horizontal asymptote. So one key rule, if you want to find vertical asymptote, always refer to the domain. If you want to find horizontal asymptote, always have to study as x approaches infinity or negative infinity. You get me? So if I get back to the graph there, so that means there is a horizontal asymptote at negative 1/3. So negative 1/3 should be around here. Y equal to negative 1/3. So my graph go like that. You see or not? Are you okay? Okay. So I recap. When you want to find the domain for a rational function, remember, if the denominator is 0, it is not defined. So therefore, the denominator cannot be 0. Then you work it out. So there is a single value of x. Yeah, so there's the first key thing. So from there, you can get your vertical asymptote. X-intercept, y-intercept is the same method throughout for any function, correct? Then how to study? So since there is a one single vertical asymptote and the x can have any left value or a right value, so the value of x can approach this vertical asymptote from the right or from the left. So you have to study slowly one by one. Are you clear? Okay. And if you want, for a rational function, if you want to study what happens if x become very, very big, positive number, or become very, very negative, then you try to change the function in such a way you divide by x for every term. So you can know how it goes. Much easier. Are you okay? I haven't mixed all the function. I can mix all the function together. Okay, I can put in exponential into a rational function. Okay, but that will be very complicated. You will see it in your chapter 2 or chapter 3. Okay, so don't worry about that. So during that time, then we will talk about it. So every function, how to get the domain, how to get the horizontal asymptote, vertical asymptote, you have to memorize that. Okay, let's try this another example. Okay, example 2. Hopefully we can complete this example. Given fx equal to 4 plus x divided by x squared plus 5x plus 6. A, find the domain. For this one, I try not to go to the graph. Okay. B, state the equations or equations of the vertical asymptote or asymptotes. So that means I expect to have 2 here. There is a reason, because the denominator is a quadratic. C, describe okay, the one describe first. Find its x-intercept and y-intercept. Describe the changes. We just study one, of y equal to fx as x approaches infinity. time factor. Okay, so for part A, you tell me I got another class on. Okay, for part A, the denominator, that is cannot be equal to 0, correct? So 6 is, the moment you see that 5, 6 is 3 times 2, or 1 times 6. 1 times 6, you will get 7. So 6 times 2, 3 times 2, 3 plus 2 is 5. Okay, so x plus 3, x plus 2 cannot be equal to 0. That is how we factorize fast. You try to find the possible product that will give you 6. And the sum will give you 5. Are you clear? Okay, so therefore, domain equal to x. X is a member of x cannot be equal to -2. So there are 2 vertical asymptotes. Are you clear? So part B, the vertical asymptotes are x equal okay. And part C, find the x-intercept, whatever on the top equal to 0. Correct? So x equal to -4. So if you can give it the answer straight away, you can say, so therefore, the x-intercept is -4. Okay, so the y-intercept, we just put x equal to 0. So I can just make a conclusion. Y-intercept is (4/6), which is 2/3. Right? Done with that. So describe the changes of y equal to fx as x approaches infinity. So now you see how I change. You look at here, here is an x squared. So what I will do is, I will divide everything by x squared instead of x. So my fx will be 4/x squared plus 1/x divided by 1 plus 5/x plus 6/x squared. So as x approaches infinity, this one approach 0, this one also approach 0. Agree with me? So you can see the picture. So my 4/x squared plus 1/x will approach 0. Correct? And my 1 plus 5/x plus 6/x squared will approach 1. But my fx will approach 0. So approach 0 from the top, because all these values are greater than 0 from above. Okay, so I just try to sketch the graph using the graphic calculator, because for this one, there is a lot of work. Other than finding the vertical asymptote and approach and so on and so forth, you also must find the turning point. So never mind, you have your graphic calculator, you will know how to get it. Yeah, so I will use my graphic calculator. Hopefully next week you try to do it. I will use my graphic calculator and get the graph. So the horizontal asymptote is x equal to 0. So, hello, can I move? Yeah, just give you have a look at the structure of the graph. So I have two vertical asymptote. What are they? No, -2, please. X equal to -2. Another one is x equal to -3, correct? So the graph go like that. The y-intercept is positive, correct? It go like that. And the other one, the x-intercept, what is the x-intercept? Negative. So it go like that. That is how the graph go. Very complex, correct? Yeah. During my time 6 form, we have to sketch this graph without graphic calculator. So I'm not going to frighten you how to sketch manually. You don't have to worry. You just need to know how to study the limit good enough. Later, you have the graphic calculator to help you to graph out the graph. Okay, how I get the graph, never mind, use this one. Yep. So you see, the rational function, anything to do with division usually is a bit complex. Am I right? A bit complex. So, but it's doable. Okay, so go back and memorize how to deal with a rational function. Okay, thank you, class.